Real-world Docker Compose project. Build a complete multi-container application. Combine everything learned so far. Use Docker Compose for orchestration. Simulate a real-world deployment environment. Project objectives. Deploy multiple services together. Configure networking. Configure persistent storage. Enable service discovery. Understand application architecture. Project overview. E-commerce application. Front-end. Back-end API. MySQL database. Redis cache. A complete application stack. Why multiple containers? Benefits. Separation of concerns. Easier maintenance. Independent scaling. Better reliability. Improved security. Modern applications use this approach. Project architecture. User. Front-end. Back-end API. Redis cache. MySQL database. Services communicate through Docker networking. Front-end service responsibilities. Display product information. Handle user interaction. Send API requests. Present application data. Users interact directly with the front-end. Back-end API responsibilities. Process requests. Authenticate users. Validate data. Access databases. Return responses. Acts as the application's brain. Database responsibilities. Store users. Store products. Store orders. Store business data. Provides persistent storage. Redis cache responsibilities. Cache frequently accessed data. Reduce database queries. Improve performance. Speed up responses. Common in production environments. Project directory structure. Project / Frontend / Backend / Docker Compose.yml. Organized and maintainable. The compose file. Docker Compose.yml. Defines. Services. Networks. Volumes. Environment variables. Acts as the application blueprint. Defining services. Services. Front-end. Back-end. Database. Redis. Each service becomes a container. Database configuration. Database. Image, MySQL 8. Environment variables. MySQL_root_password. MySQL_database. Database starts automatically. Database persistence. Volumes. MySQL data /var/lib/MySQL. Benefits. Persistent data. Survives restarts. Supports backups. Redis configuration. Redis. Image, Redis. Lightweight. Fast. Easy to deploy. Compose handles setup automatically. Backend configuration. Backend. Image, e-commerce backend. Environment variables. DB_host equals database. Redis_host equals Redis. Service discovery. Backend. Database. MySQL container. Docker DNS resolves service names automatically. Frontend configuration. Frontend. Image, e-commerce frontend. Ports. 3000:3000. Users access the application through this service. Complete communication flow. User. Frontend. Backend. Database. Redis. All services communicate through Docker networking. Automatic network creation. Docker Compose Up. Automatically creates. Networks. Containers. DNS entries. No manual setup required. Persistent data flow. Application. Database container. Docker volume. Persistent storage. Data survives container recreation. Starting the application. Command. Docker compose up. Compose creates and starts the complete stack. Running in detached mode. Command. Docker compose up D. Benefits. Background execution. Continuous operation. Better productivity. Viewing running services. Command. Docker compose PS. Displays. Status. Container names. Port information. Monitoring application logs. Command. Docker compose logs. Provides centralized logging for all services. Viewing logs for one service. Command. Docker compose logs backend. Useful for troubleshooting specific services. Updating services. Build new image. Update configuration. Restart service. Deploy new version. Individual services can be updated independently. Scaling services. Frontend instance 1. Frontend instance 2. Frontend instance 3. Backend. Database. Docker supports service scaling. Failure recovery. Frontend failure. Restart frontend only. Backend and database continue running. Improves reliability. Security benefits. Service isolation. Network segmentation. Controlled communication. Reduced attack surface. Containers improve application security. Production architecture example. Web application. API layer. Redis cache. MySQL database. Common architecture in modern applications. Growing application complexity. As applications grow. More containers. More networks. More storage. Compose helps manage complexity. Benefits of Docker Compose. Centralized configuration. Automated networking. Persistent storage. Service discovery. Easier deployments. Common beginner mistakes. Missing volumes. Hard-coded IP addresses. Exposing too many ports. Incorrect environment variables. Best practices. Use meaningful service names. Store data in volumes. Limit port exposure. Separate application layers. Keep configuration organized. Project workflow. Create compose file. Define services. Configure storage. Configure networking. Docker compose up. Application running. Skills acquired so far. You can now build images. Run containers. Manage volumes. Configure networks. Build multi-container applications. Use Docker Compose. Interview question. Question. Why is Docker Compose commonly used in multi-container applications? Answer. Docker Compose allows developers to define and manage multiple related containers using a single configuration file, simplifying deployment and service management. Key takeaways and lesson summary. Real-world applications use multiple containers. Docker Compose manages complete application stacks. Services communicate through Docker networking. Volumes provide persistent storage. Service discovery simplifies communication. Compose improves deployment and maintenance workflows.